finish all of it. I left some questions out
Hmm.
because I was like, oh my god, it's already like almost midnight, and I was still like doing it.
Uh-huh.
So I mean, so I was like, okay, I'll just get whatever I get, but I did as much as I could.
Okay.
Um, I'm trying
Okay.
to. I took a, yeah, I took a picture of a question. I'm just trying to find it.
Okay.
I was like, did you have it? Do you have the test with you?
I do. I've got the practice test open, uh,
Okay.
but the questions may
Um,
be in different orders, so I may have to hunt for it a bit.
okay. This one said it was number for me. It was number 41, and
Okay.
it said find uh multiplicative the multiplicative inverse of each following. So it was like -1/7, and then is, and then I had to put something right there.
Okay. Great. Let me see what happens if I push this button here. I don't want to do that. Okay. Let me just see if I can take it from, rather than hunting for it, we'll just do it from here. Find the multiplicative inverse of, go ahead and give me one that you'd like to. I know that one's a
Um,
to it. Whichever one first.
so I guess it was like -1/7, and then B was like a what's it called, a mixed number. It was three. The whole number is three, and then it was 4/5,
Okay.
and then the y/x. I pretty much knew that that was gonna like flip, so I knew it was gonna be x/y.
Right, right.
And then the other one was -2.
Okay. So 3 and 4/5 was one of them, and -2 wasn't another one.
Yeah. And then
And
the
another one was
uh,
that
negative
first one.
1/7.
Okay, great. All right. Okay, so multiplicative inverse is really just a fancy word for reciprocal. That's all that means. But to work, let's say, with this mixed number, can you see that okay? The 3 and 4?
Yeah, I can see it.
Okay,
Yeah.
great. To work with that in order to find its inverse, what you're really going to have to do first is convert it into an improper fraction.
Hmm.
So what you're going to do is you're going to do the trick of taking the 5 times the 3 added to the 4, where you take this number times this number plus this number, uh,
Okay.
and write that over 5. So 5 times 3 plus 4. Now what that will do is, oh shoot, I didn't want that infinity there.
No.
What that will do is on the top you'll get 19. 5 times 3 is 15 plus 4 is 19. So
Okay.
now all this does is it says that 3 and 4/5 is the same as 19/5. That doesn't tell
Hmm.
you what the reciprocal is. But if you take that and just flip it over again, then the reciprocal of that becomes 5/19. Okay.
Okay.
So make a mixed number, make an improper fraction out of it first, and then take the reciprocal.
Okay. And then, so 5/19 would be the, oh yeah,
Yeah,
that
five over
would be the
19.
answer. Yeah. Okay.
Sort of similarly, if you have a whole number, you have to make that into a fraction before you can do anything else. Any whole number can be written as itself over 1. So I can write the -2 as -2 over 1. And then if I want the reciprocal of that, or multiplicative inverse to be the $1,000,000 word, you can flip that over, and that would give you,
Oh, okay. So that's where the -1/2 comes from.
yeah. Now, if you literally flip it over, you would have 1/-2, But a positive over a negative is a negative. And so you could write that as either negative, the 1 over negative 2, the way I've got it, or negative 1 over 2, or even negative 1 over 2. And all three of those should be equivalent, and it should accept any one of them.
Okay. Oh, okay, so I get it. Okay.
Okay. And then for negative 1 over 7, if you want the inverse of that, flip it over, and you would get 7 over negative 1. But 7 over negative 1, you would probably simplify. A positive divided by a negative is a negative, and anything over 1 is just itself. So I'd write it as 7.
Okay. Okay. Okay, I get it now.
Yeah, it all builds on that idea of just take the fraction and invert it. But these are all special cases, basically, that you have to think about.
Okay. I think one more I had was it was in each of the following order of the decimals from greatest to least. I think what I'm having trouble with the negative ones is putting those in order from greatest to least.
Oh, yeah, because you are having to think sort of backwards. And that is.
Yeah, and that's what I was trying to think, like, the number line, I guess. But for some reason, I keep getting, like, I'll get the first part, like the positive numbers right, but the second part is just, like, it throws me off.
Mm-hmm, mm-hmm. Do you, let me, hold on a second. Are these repeating decimals the example you're looking at, or just regular ones?
Yeah, like the ones that have the repeating decimals with the sign over it.
That's the toughest one. Yeah. That's the toughest. Yeah. Let me see. See what happens if I close that.
There's not going to be that many questions, right, on the test?
No.
Okay.
Hi, Allison. How are you? Yeah, the actual test. This is going to be like maybe 1/4 of the size of the practice test, and in particular, there almost every problem on the practice test, it like gives you 3 or 4 of nearly the same kind. There's only going to be like one. Like this last one did these reciprocals. There would be one of them, not 5 of them. So.
Okay.
Can you, for the one you're working on getting them in order, can you tell me what some of those look like?
So,
yeah,
hi, Allison. Okay. So the numbers is from greatest to least, and it's negative 2.686 with the line over the 86.
I pushed the wrong button and made a mistake here. Let me try. Okay, so sorry. Go ahead and tell me again.
Okay, so it's negative 2.686. And it has the line over the 86.
Over the 86. Okay. So that's one of them.
Okay, and the next one is negative 2 point, and the line is over the 686.
Okay. Okay.
The next one is negative 2 point. The line is over the 68.
Okay.
The next one is negative 2.686, and the line is just over the last 6.
Okay. 6, 8. And the line is just over the 6. Okay.
And then the last one is
oh, woo. This program acts weird. Okay, go ahead.
Okay, the last one, there's no line on top, so it's negative 2.686.
Okay, great.
And then going from greatest to least.
Greatest to least. Okay. So here's what I think you have to do to make sense out of it. I want to really see more of what those decimals look like. So I'm going to, instead of relying on the line, I'm going to write out some of the more digits. So instead of saying 686 with a line over it, I'm going to say 6 and then realize that the 86 repeats. And I'm just going to put a bunch of those. And then some dots to represent that it goes on forever and ever. So that's what the first one looks like. And then the second one would be the whole 686 repeating. 686, 686, 686, 686, 686, and so on and so forth and so on. And then this one would be negative 2.68, 68, 68, 68, 68, 68, 68. I'm sure I don't really need that many places, but oh well. Oops, not greater thans. This one would be negative 2. The only thing's repeating is that last 6, so it goes 6, 8, 6, 6, 6, 6, 6, 6, 6, 6, 6, 6. And then finally, the last one doesn't have any repeating places. But what I could do is I could just put in zeros.
Okay.
It'll have zeros forever and ever. Then what you can do is you can compare them place by place, looking for places where they're differing from one another. So like if I look at the negative 2.68, that is the same in all of these. They all have a negative 2.68. They all match through the first 2 decimal places. In fact, they really all match through the first 3. They all have negative 2.686, I think. Yeah, they all do. So the first place where there's any difference is in the 4th decimal place.
Yeah.
And that's where you can begin to compare them. Okay. So I noticed this one has an 8. This one has a 6. This one has a 6. This one has a 6. And this one has a 0. So we're thinking negative. So the larger numbers on the number line, the smaller numbers on the number line, on the negative side, are when the digit is largest. That may not have been elegantly said. Let me try it again. So if you think about how the number line works, when you're looking to the left, the absolute values of the numbers get bigger as you go to the left, but the numbers are getting smaller.
Yeah.
So like a negative 9 is smaller than a negative 4.
Correct.
Okay.
Yes.
So looking in these 4th places, there was only one of them that had an 8 in the 4th place. That means that that's going to give it the position of being the smallest.
Okay.
So I know that one. This is the smallest one. Okay. So let's continue to look in these 4th places where they begin to differ. I've got a 6 here, a 6 here, and a 6 here. So that doesn't help. I'll have to look more carefully at those 3. But this one in the 4th place has 0. Well, 0 in absolute value is the smallest, but that makes the number the largest because we're looking at negatives.
Yeah.
Okay, so that makes this one the largest. So at least I know who's smallest and who's largest. So far, so good. Now, all 3 of these matched in the 4th decimal place, so that means you have to go to the 5th one. So in the 5th place, that's got an 8, that's got an 8, and this one, 1, 2, 3, 4, has a 6. So these 2 are still matching, but this one has the smaller digit in absolute value, which means among these 3, it's the largest of those 3.
Okay.
Now this number on the bottom was the largest overall, so this one is going to end up being the 2nd largest.
Okay.
Okay. Now, I still have controversy between these two guys because they matched in the first, second, third, fourth, and fifth decimal place. Looking at the sixth place, oh, look, they still tie. 1, 2, 3, 4, 5. Oh, count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, no, they don't. We're going to be able to break the tie now. This one has an 8 in the sixth place. This one had a 6. So this one that I've got marked right now would be the next largest. Is that right?
Yeah, so the third largest.
So this would be the third largest. And then that would make this one the fourth largest. Second smallest, however you want to say that.
Yeah.
And now you can put them in order.
Oh, okay.
Okay.
Yeah.
So
okay.
yeah, you really have to write out all the decimal places and then just go place by place by place by place by place until you begin to see them mismatching, and then you can make decisions.
Okay.
And then throw the negative in, and you have to remember you're reading it all backwards. So
Yeah.
Look
Yeah,
good?
that makes much more sense. Yeah.
Great, 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 great. Save that so we can have it for later. Good, good. All right. What else? Allison, do you have one you want to ask?
I'm actually was just and seeing if anyone else has questions. Right now, I haven't had the chance to look at practice test 3, but right now I'm skimming it. If you have any more questions, go ahead. But I'm gonna look right now. But I think I grasped everything. I was just here to listen.
That's a good thing to do. You never know when you might get that one extra thought that turns out to be the thing that makes a difference. So
Yeah,
no.
the question you just went over actually was the one that I was struggling with, so that helped.
Oh, great, 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 great. Good. Okay, Amy, why don't you go ahead then, and we'll just see what you've got. And Allison, if you see one that you want to ask, we'll just let you jump in too.
Okay.
I think that was hold on. Oh no, there's one more. Okay. I think this is my last one. It was for each of the following, find two rational numbers between the given fractions. And the first one was A was 1 7 and then a comma 2 over 7. And then for B it was negative 2 over 5 and then comma negative 3 over 5.
So that's one of them. And the other one was find two rational numbers between. And tell me those.
Negative 2 over 5 and negative 3 over 5.
Okay, great. Okay, very good. So there's a real simple trick on these that is going to work on both of them. Let me get this guy back up here again. So if I look at 1/7 and I look at 2/7, it's really hard to see that there might be a fraction in between those somewhere. But what you can always legally do is multiply numerator and denominator of the fraction by the same thing.
Okay.
Let me show you a couple things, and then I'll tell you why I'm thinking, or why they're thinking what they're thinking. So one thing you could do is say, well, I could multiply the top by 2, and that's perfectly legal as long as I multiply the bottom by 2. And that would make this fraction the same thing as, keeps doing that, 2 over 14.
14.
And if I do the same thing here and multiply this by 2 and this by 2, sorry, my software is a little clumsy here. This would give me 4 over 14. So those are actually the same two fractions that I started with. When I look at them this way, and think about could there be a fraction in between them, you actually can realize that there is one. Because between 2 over 14 and 4 over 14, you would have 3 over 14. So that in general gives me a way to find a fraction between any two fractions. But the problem is they wanted two fractions in there. And with 2 over 14 and 4 over 14, there's only one obvious choice. But if you see what happens, by multiplying by 2, I was able to spread them apart enough to where I could get one fraction between them. If I'd done the same trick and instead of multiplying by 2, if I'd multiplied by 3, which would still be legal, 1 times
So, can I ask, where are you getting the 2 from? Like multiplying the 2 from?
it's just a number I chose.
Oh, okay, okay.
It was literally the smallest integer that would make a difference. If I'd multiplied by 1, nothing would have happened. So I just said, well, what about 2? And it works, but it doesn't get you the 2 numbers that you want. So if you multiply top and bottom by 3 instead, the 1 over 7 becomes 3 over 21. And the 2 over 7, if I multiply by 3, that the key is you want to choose the same number.
Yeah.
7 times 3. Let's see what happens here. So 2 times 3 would be a 6 over 21. Now, if I think about it, between 3 over 21 and 6 over 21, I could have either, that didn't work right, either a 4 over 21 or a 5 over 21. Now there is a pattern you can build on here. If you only need one fraction between two fractions, multiply top and bottom by 2. If you need 2 fractions, multiply top and bottom by 3. If you need 3 fractions, multiply top and bottom by 4.
Yeah, because the answer ended up being 4 over 21 and 5 over 21.
Right. Yeah, because I needed to get enough space in there to find 2 fractions. Multiplying top and bottom by 3 is what worked for me.
Okay.
Is that cool?
Yeah. Uh-huh.
Yeah, so the other one actually will work the same. Let me just post this there for all eternity. This you can do the same thing. Find 2 rational numbers between -2/5 and -3/5. Even though it's negative, that doesn't actually cause much of a problem. It's negative 2 over 5. But if you want to get 2 numbers in there, multiply the top by 3 and the bottom by 3. And see, actually, you could multiply top and bottom by 4, 19, 25, anything you want. But these are the ones that can give you the answers that you're seeing just from having done it. So there's actually infinitely many correct answers here. This is really the same as -6/15. And then the other one would be a -3 over 5. Again, multiply the top by 3. Didn't do what I wanted.
And then does it like subtract 1? Because the answer for that one ended up being -7 over 15, -8 over 15.
Yeah, let me show you how this works. It'll be pretty obvious, I think.
Okay.
This would give you a -9 over 15. And so in between -6 over 15 and -9 over 15 would be -7 over 15 and -8 over 15. Just the two numbers in between.
Oh, okay.
And I could have multiplied by top and bottom by 4, and that would have given me different numbers, but this one set up multiple choice and they multiplied by 3.
Okay.
Yeah, that's a clever one. The fancy word there is to say that the rational numbers are dense, which means between any two fractions, you can always find another fraction.
Oh, okay.
So, and this is the trick you use.
All right. Well, I think that was just all the 3 questions for me that I had on the test.
Okay.
Yeah. I think everything else I pretty much kind of remembered from the homework and stuff.
Okay. Yeah, these are good ones. These are, I think these are particularly good questions because they are, I find these tricky because you have to look at all the decimal places to really see. And then these questions are unusual because they're not the usual add, subtract, multiply, divide kind of things.
Yeah.
So good.
Okay. Well, thank you.
Okay. Allison, do you see any? I mean, it doesn't matter that you haven't worked them, but if you page through, it's like, not sure I can do that one or anything.
Yeah, for sure. I have question number 43. One second. Okay, so I remember this one at the homework, and I didn't really understand it. It says Jennifer weighs. Oh, Amy, did you want to leave?
I'll listen to it.
Yeah, stick around. Love to have you.
Okay, so Jennifer weighs 180 pounds on Earth and 432 pounds on another planet. Find Anne's weight on that planet if she weighs 120 pounds on Earth.
Great. I need those numbers again. Can you read it to me again, real slow?
Sorry. Jennifer weighs 180 pounds on Earth
Mm-hmm.
and then 432 pounds on another planet. Then find Anne's weight on that planet if she weighs 120 pounds on Earth.
Anne's weight on that planet if she weighs 120 pounds?
Yes, on Earth.
Okay. Excellent. So Jennifer weighs 180 pounds on Earth and 432 pounds on another planet. Find Anne's weight on that planet if she weighs 120 pounds on Earth. This can be set up as a proportion problem. So what I'm going to do, let me get this to where we can see everything. You can make a fraction that describes what's going on with Jennifer. She weighs 180 pounds on Earth. Let me just do it this way. While she weighs 432 pounds on the other planet. That fraction has to be proportional to Anne's fraction. So if you put weight on Earth over weight on the other planet, it should match weight on the Earth versus weight on the other planet. So if Anne weighs 120 pounds on Earth, well, we don't know how many pounds she weighs on the other planet, so let's just call that X. Okay, so weight to weight, weight to weight for Janet, Jennifer, and one for Anne. And the important thing is if you put the weight for Jennifer on Earth on the top on the first fraction, then the weight on Earth for Anne has to be at the top of the second one. So you're keeping it balanced like that. So far, so good?
Oh, yeah. Yeah.
Okay. So if I take out all of the words because they're just going to kind of get in the way, what I really am doing is I'm solving the proportion problem 180 over 432 equals 120. Oh, why does it keep doing that? I'll get it right here in a minute. 120 over x. Now, what you can do there is you can cross multiply to solve for x. So if you multiply the 180 times the x, multiplying this way, and the 120 times the 432 going this way, see what I'm doing there?
Mm-hmm.
Okay. Then you can go get your calculator and say, okay, what is 120 times 432? That's 51840. So 180x equals 51,840. And then what would I do to get the x by itself?
Divided by 180.
Exactly. So you take the 51840. Oh, excuse me. Put that in the wrong place. I forgot I wasn't over on the calculator. Okay, here we go. 51840 divided by 180. And that should be it.
Okay.
So the answer should be 288 pounds.
All right. I had two more.
Sure. Let me just do this real quick. Okay.
Okay. So on a map, 1/3 inches represents 5 miles. If two cities
Okay.
are 19 inches apart on the map, what is the actual distance between them?
This is another one that could be set up as a proportion problem. A little bit weirder because it's got some fractions going on. Let me show you here. So if you think of a proportion where on the map, 1/3 inch represents 5 miles, you can make a fraction out of that where the numerator would be its own fraction. I would say 1/3 inches corresponds to 5 miles. That's what it is on the map. So in real life, the ratio has to be the same, inches to miles, inches to miles. So between these two cities here, on the map, they're 19 inches across. You don't know how many miles that is. Okay. So 1/3 inch represents 5 miles. 19 inches equals you don't know how many miles. And that creates another proportion problem. Does that look all right so far? Okay. Cross multiply here, and you'd be taking the 1/3 times x. So 1/3 times x equals 19 times 5. Then you go over on your calculator and you say 19 times 5 equals 95. So 1/3 x equals 95. Now, I've got to find out what x is from there. So this is kind of an algebra question. We can still solve it here, I think. If I want to get rid of that 1/3, how would I do that?
95.
Yeah, exactly. So you would say x is equal to 95 divided by 1/3. Now, how do I divide something by 1/3?
Use the calculator.
Yeah, we're gonna use the calculator in a minute. I could actually do everything on the calculator. I'll show you how in a minute. But you can also think of it this way. When you're dividing by a fraction, it's the same as multiplying by the reciprocal. So dividing by 1/3 is the same as multiplying by, take the 1/3 and flip it over, 3/1.
Mm-hmm.
So it'd be 95 times 3.
Okay.
So you can do this either way. You can either say on your calculator 95 divided by, and then the way you'd handle the dividing by 1/3 is because you want that 1/3 to stay together, you'd put parentheses around it. That would be 95 divided by 1/3.
Mm-hmm.
Or if you use this reciprocal idea, you should get the same thing if you say 95 times 3. And you do.
Okay. Okay. And what kind of problems did you call this again?
These are called proportion problems.
Portion. Okay. So last one.
They are covered in section 7.4, just because I just happen to remember.
Okay, 7.4.
I often can't do that and quote the section number for you, but that one I happen to remember.
Okay. Okay, so this one's for fractions. It says change the following mixed number to a fraction in the form AB. And it's the 5 and then 1/4. So it's a mixed number.
Great. So 5 and 1/4. Okay. We want to make that to a mixed number. Okay. Now, the way that works, the process is pretty simple. What you do is you take the denominator, you multiply it by the whole number, and you add the numerator. So it would look like this. You'd say 4 times 5 plus 1. This number times this number plus that number. 4 times 5 plus 1.
Mhm.
All over, the denominator stays exactly the same. You don't do anything with that. 4 times 5 is 20, plus 1 is 21. So this becomes 21/4.
Okay.
And that's the improper fraction they wanted.
Okay. The B is -1 5/7, another mixed number.
Okay.
It would just be the same process.
Yeah. What was it again?
Oh, -1 and then 5/7.
Okay. Okay. Yeah, that's not going to change very much. But let me show you anyway, just in case.
Mhm.
What you're going to do is you're going to leave the negative alone. That's worth noting, I think.
Mhm.
So the negative is just going to go along for the ride. It's not really part of the mixed number. I'm thinking of this part as being the mixed number. So I'll just leave the negative alone, and then the fraction would be 7 times 1 . 7 times 1 plus 5.
Yes.
So it's not 7 times -1 is what I want to point out there. The negative is just off to the side. So that would become then a negative, and the fraction itself would be 7 times 1 is 7 plus 5 is 12. Negative 12 sevenths.
Okay. Fractions are tricky for me.
Mhm.
All right. Okay, so that's all the questions that I've seen that I needed help with. But if I do find more, because I'm gonna finish this tonight, I could just email you, right?
Absolutely. Yeah. Yeah. Email me. I can send you answers back by email. If it's really tricky, we can actually even set up a separate WebEx either later tonight or tomorrow, at a time we can arrange, and we can do it this way too.
Okay. Okay.
Whichever works best.
Okay. Okay. Well, that's it. I thought more people were gonna be here. I thought this was gonna be like a goodbye, you know?
Oh yeah, yeah, kind of. It's kind of almost wish it were.
Yeah.
I was afraid no one was going to come for a while, but I'm really glad y'all were here. I hope this was helpful. Amy, could you think of anything else you wanted to ask as you look things over?
No, I think I'm good. I'm just, I guess, anxious to go ahead and take it and get it over with.
Get it over with. Yeah, it opens at midnight
Yeah.
tonight. So if you want to get it out of the way, anytime after midnight tonight works. But it's open all the way through
Okay.
Saturday, so whatever works. Um, Yeah, I have felt very sad that this class got taken away from the face-to-face format because we didn't get to do the stuff in class that I really wanted to. I wanted to actually show you how the manipulatives worked, and instead I've just had to have you watch videos. And but I hope this has been a good class anyway, that you've got a lot out of it. And hopefully it'll help you feel
Yeah.
confident in your teaching.
Yes,
Yes,
of
I
course.
have learned a lot.
Oh, good. I'm glad. I'm glad. Very, very good.
I've already had you
Yeah.
a semester, so I knew that you're a great teacher, and it really sucked working online because you're so great in person and then
Yeah.
moving to videos. But thank you for being so accommodating to everything. You've been very helpful.
Oh, you're very, very welcome. You're very well welcome. Yeah, this would have been I'm really more a face-to-face teacher than an online teacher. So but I think we've managed to get through. So I'm glad. So um hopefully it was a really good experience. Do great on your test tomorrow, and whenever you take it, doesn't have to be tomorrow. It can be Saturday, Friday or Saturday too. But good luck, and good luck with the rest of your classes and your whole career, everything.
All right. Thank you.
Okay. All right. Well,
Safe. Stay
y'all,
safe.
thank you. You too. You too. Stay well, stay safe. And if you need me, email me. I'll be glad to answer any other questions you got.
Okay.
Okay. Great. Okay. Y'all take care.
All right.
See you later.
Bye.
Bye
Thanks.
bye.
Thank you.